Hey everyone, ready for another deep dive? Today we're going to tackle something that sounds super complicated, but I promise, by the end of this, you'll be able to impress all your friends with your quantum computing knowledge.
That's right, we're aiming to demystify quantum computing.
And we're going to do it with the help of this super cool podcast I found called Mind-Bending Tech. They break down some really complex stuff using analogies that honestly kind of blew my mind.
Analogies are a fantastic way to make these concepts click.
Yeah, so okay, let's unpack this. First things first, right? We've all heard of bits.
The ones and zeros that regular computers use.
Exactly, like on or off switches. But quantum computers use these things called qubits, and that's where it starts to get a little weird.
Well, think of it this way. A regular bit, it's like a coin, right? Heads or tails.
Got it, makes sense.
But a qubit, it's like that coin is spinning, it's both heads and tails at the same time until it finally lands.
Whoa, wait, it can be both at the same time?
Exactly. It's called superposition, and it's mind-blowing, right? And that's what gives quantum computers so much power.
Okay, I am trying to wrap my head around this. So instead of just being a 1 or a 0, it can be both, and everything in between.
You got it. All at the same time.
So is this kind of like, I don't know, is it like mind-bending tech mentioned parallel universes? Is that what's happening here? Are we talking about other dimensions?
Well, that's a fun way to think about it, but not exactly. It's not that they're jumping between different universes. It's more like they can explore all possible solutions to a problem all at once.
So like, it's not magic, but it kind of sounds like magic.
Right. Harnessing the weirdness of the quantum world to solve problems. It's incredible, really.
Okay, but how does that actually play out? Like, how does that translate into, I don't know, real-world problem solving? Because mind-bending tech was talking about how quantum computers could, like, solve problems in seconds that would take a regular computer millions of years. Is that even possible?
It is, absolutely. Think about a problem like simulating how a new drug interacts with the human body. That's incredibly complex. With a classical computer, you'd have to test each possible interaction one by one.
Right, which would take forever.
Exactly. But a quantum computer, it can explore all of those possibilities at once because of superposition. It lemmatically speeds up the process of drug discovery.
So it's like hitting fast forward on scientific research.
You could say that, and it's not just medicine, it's everything. Analyzing massive amounts of climate data, designing new materials, the possibilities are mind-blowing.
This is insane. Okay, I get why everyone's so excited about this now, but this all sounds so complex. Is this something that only, like, super geniuses can understand? Can someone like me actually wrap their head around this stuff?
Of course, anyone can learn about quantum computing. It might seem intimidating, but there are tons of resources out there that break it down into, manageable pieces.
So where should someone even start if they want to dive a little deeper? Like, where should they go?
Well, Mind-Bending Tech had some great suggestions. They talked about IBM's free quantum simulator, which lets you experiment with quantum circuits and see how they work. You don't even need any special equipment.
Wow, that's pretty cool. So, like, hands-on experience without needing a lab coat?
Exactly. And of course, there are tons of great YouTube channels that break down these concepts in super simple ways.
Perfect for visual learners like me. Okay, so I think we've covered the basics of what quantum computers are, how they work, but we're just scratching the surface of the real-world applications of this tech.
That's right. We've got a lot more to unpack.
So stay tuned, because in part 2, we're going to dive into some of those mind-blowing applications.
Welcome back, everyone. Ready to see how this quantum stuff could actually change the world?
Oh, absolutely. I'm super curious to see how these mind-blowing concepts translate into, like, real-world action.
Well, one area where quantum computing holds massive potential is medicine, like in drug discovery. Remember our library analogy?
Yeah, where a quantum computer could search every book at the same time.
Exactly. So imagine applying that to like searching for a new drug. A classical computer has to analyze each molecule one by one, like reading every single book in that library. But a quantum computer, it can explore all possible combinations simultaneously.
So instead of years or even decades to develop new drugs, we could be talking about, what, like weeks? Days?
Potentially, it could radically speed up the whole process.
That's insane. Are there any, like, specific examples of how researchers are actually using this right now?
Oh, absolutely. They're already using quantum computers to simulate the behavior of molecules.
Okay, why is that important?
Well, it's crucial for understanding how drugs actually work, right? And for designing more effective treatments. It could lead to breakthroughs in everything from cancer to personalized medicine.
Whoa, personalized medicine tailored to your specific genes. That's the future. Speaking of the future, Mind-Bending Tech also mentioned AI. How does quantum computing play into that?
Well, think of it this way. AI relies on algorithms that learn from huge amounts of data. And the more data, the smarter they become. But classical computers, they struggle with massive data sets.
Oh, so they kind of get bogged down.
Right, but quantum computers, they can process information at insane speeds. Imagine AI that can accurately predict natural disasters, optimize traffic flow in cities, personalize education.
It's like giving AI a brain boost. Okay, but this all sounds a little too good to be true. Are there any downsides to quantum computing? Like, what are the risks?
That's a really important question. Like any powerful technology, it's got its challenges. Cybersecurity is a big one.
Oh, yeah, because earlier we were talking about how quantum computers could crack our current encryption, right?
Exactly. That means everything online, from our banking to our personal data, could be vulnerable.
That's a little scary.
It's a serious challenge, but don't worry, researchers are already working on new encryption methods that can withstand quantum attacks.
So it's like a constant race, right? The good guys versus the bad guys, always trying to stay one step ahead.
Pretty much. And then there's the sheer complexity of actually building these things. Qubits, they're super sensitive to their environment, like really prone to errors.
Oh, I see. So keeping them stable is a big hurdle.
Huge. But researchers are making progress. They're developing ways to better control qubits and correct errors.
That's good to hear. But all this talk about super fast computers and AI, it makes me wonder, are our jobs safe? Are we all going to be replaced by machines?
That's a valid concern, but history shows that technological advancements often create new job opportunities. Look at the internet. It's disrupted tons of industries, but also created tons of new ones.
So you're saying quantum computing could lead to new industries and jobs we haven't even thought of yet?
Exactly. Instead of fearing it, we should see it as a chance to learn new skills and adapt. We'll need people to design, build, program, and maintain these systems.
Right. It's not about jobs disappearing. It's about them changing.
Exactly. And it emphasizes how important education and trainer are. We need to prepare for a future where quantum computing plays a huge role.
Okay. So exciting potential, but challenges too. Anything else we should be thinking about as this technology keeps developing?
Well, ethical implications are crucial. As this technology gets more powerful, we need to think about how it's used. We have to make sure it benefits everyone, not just a select few.
So it's not just about the tech itself. It's about our values and principles too.
Right. We need open discussions about its impact on society and clear ethical guidelines.
It's like we're at this, I don't know, crossroads. We have the chance to shape the future of this incredible technology in a way that's good for everyone.
Absolutely. And that's a responsibility we all share. Scientists, policymakers, businesses, everyone.
Well, this has been an incredible deep dive. We've covered a lot of ground, but obviously there's still so much more to explore.
Oh, definitely. And in the final part, we're going to look at specific resources and actions you can take if you want to learn more or even get involved in quantum computing.
Ooh, I'm already excited. So stick around, folks. We'll be right back with more on the mind-blowing world of quantum computing. All right, we're back. So I got to admit, my brain is still buzzing from all this quantum talk, but in a good way.
It's definitely mind-bending stuff, right?
It is, but super exciting. So for those of us who, want to go beyond just listening and actually learn more or even get involved, like, where do we even start?
Well, remember how mind-bending tech mentioned some resources?
Yeah. What were those again?
One of the coolest ones is IBM's Quantum Experience.
IBM, like the computer company.
The very thing. They have this free online platform that lets you run actual experiments on real quantum computers.
Wait, really? We can actually access quantum computers? I thought that was like top secret government stuff.
Not anymore. It's getting more accessible all the time. IBM's platform has this user-friendly interface and tutorials, so even if you're not, a quantum physicist, you can still get a feel for how it all works.
So you're telling me I can write my own quantum program and see it run on an actual quantum computer?
Yep, that's the power of it. You can learn by doing.
That's insane. Okay, got to try that. What if, someone's more of a visual learner? Any suggestions for them?
YouTube, my friend, tons of amazing channels out there dedicated to explaining this stuff in really simple, engaging ways. Quantum computing for everyone, the Quantum Daily.
I'm writing these down. Okay, so we got the hands-on stuff, the visual stuff. What about, the hardcore theory?
Mind-bending tech recommended some good books, too. Quantum Computing for Dummies is a great starting point. Or Dancing with Qubits, if you want to go a bit deeper.
So no matter your learning style, there's something out there. I love it. But, okay, let's say someone wants to, I don't know, actually contribute to this field. Is that even possible if you're not, a scientist or engineer?
Of course, online communities and forums are a fantastic way to connect with other quantum enthusiasts.
So, a global brain trust of quantum nerds.
Exactly. Sharing ideas, collaborating on projects, and if you're feeling really ambitious, there are online courses and programs that teach you quantum programming.
So even if I don't become a full-blown quantum expert, I can still pick up some valuable skills.
Absolutely. It's all about being curious, exploring, and seeing where this incredible technology takes us.
Well, I think it's safe to say my mind has been officially blown wide open by this whole deep dive.
Mission accomplished. It's such an exciting time to be following this field. The potential is just limitless.
It really is, and honestly, even if I never write a single line of quantum code, I'm just so glad to be living in a time where all this is happening.
I feel the same way. We're witnessing the birth of a new technological era. It's mind-blowing.
Well, we've reached the end of our quantum journey for today, but seriously, this is just the beginning. Keep those minds open, folks. Keep exploring. Keep learning.
And don't forget, the future of quantum computing is in our hands. Let's make it a good one.
Couldn't have said it better myself. Huge thanks to Mind-Bending Tech for the inspiration and to all of you for joining us on this wild ride. Be sure to like, share, and subscribe to The Deep Dive for more explorations of the future. And as always, leave a comment below with your thoughts, questions, or any cool quantum facts you stumble upon. Until next time, keep those brains buzzing.